In today's class, we will solve a few problem sums based on real numbers, LCM and HCF, which are of level 2. So let's get started. The first problem sum says that find the greatest possible length of the rope that can be used to measure two sticks of length 24 meter and 18 meter. So the key point is we have to find the greatest possible length of the rope that we can use for measurement. Now the lengths of two sticks are 24 meter and 18 meter. So as far as the understanding of this problem sum goes, that the length of the rope will be such that the 24 and 18 will be multiple of that length, means length of the rope, right? Now suppose if we choose the length of the rope as 1 meter, then if it is 1, then definitely 24 and 18 or any other number will be multiple of 1. But what will happen in this case, to measure the stick of length 24 meter, we have to repeat that measurement or that process 24 times, since the length of the rope we have chosen as 1 meter. And to measure this stick, which is of 18 meter length, we have to repeat that process or that measurement 18 times. But that is not acceptable. So what we have to do? We have to increase the length of that rope. And that's why in the question it is given that greatest possible length, so that repetition for measurement of these two sticks will be reduced, or that will be minimum. If the length of the rope chosen is greatest, then that repetition of the process or measurement will be least. So now from 1 to now, if we increase the length of the rope as 2 meter, then it will be this. For 24 meter the repetition will be 12 times, and for 18 meter the repetition will be 9 times. And what we have seen here, that 1 or 2, whatever, these numbers, these are basically the common factors of these two values or these two lengths, 24 and 18. That means we have to choose the length of the rope such a way that that will be a common factor of these two values, and that will be the greatest common factor. So basically here the solution of this problem sum will be, we need to find the greatest common divisor or highest common factor of these two numbers. So if we do that, then the HCF of these two numbers will be 6. We know that rule. And the greatest possible length of that rope will be 6 meter. Now if we measure by this rope, which is of length 6 meter, then we have to, for this stick, we have to repeat that process for 4 times, and this is for 3 times. And there is no other value, or there is no other factor of 24 and 18 which is more than 6. The next problem sum says that we have to reduce this to its lowest terms. First, we will factorize both the numerator and denominator. So now if we represent 6912 upon 6561 as the multiplication of their factors, then it will be, now if we look at these factors, then we can see that in the numerator and in the denominator we have one common factor, which is 3, and that is 3 in number. So those 3 factors will cancel each other. So this 3 and this 3 will cancel each other, and rest of the factors are different. In the numerator and denominator there is no more common factor. So basically this 3, and if we multiply 3, then it will be 27. So 27 was the greatest common divisor or highest common factor of these two numbers. So they cancelled each other. Now if we simplify this, then it will be, now the next problem sum says if a number which is given as 2345 P60Q. So here the two unknown digits are there, P and Q, is exactly divisible by 3 and 5. Then what is the maximum value of P plus Q? So we have to find the maximum possible values for P and Q, and then we have to add them. So first of all, this number which is given, that is divisible by 5 and also 3. Now if we go by the divisibility rule of 5, then we know if of a given number, if the last digit is 0 or 5, then that number is divisible by 5. Now we need to find the maximum value of P and Q. So here the two possible values of Q will be 0, either 0 or 5. So here the maximum value between 0 and 5 is 5. So that means the maximum possible value of Q is 5. And now we need to find the maximum value of P. So now we will go for the divisibility rule by 3. We know that if the summation of all the digits in that given number, if that is divisible by 3, then the whole number will be divisible by 3. Now if we add all these digits of that given number, then it will be 2 plus 3, then plus 4 plus 5, and then we have P, then we have 6 plus 0 plus q, which is 5 that we have already found. So it will give us 25 plus p. Now we know that 25 is not divisible by 3. So the next possible value which will be divisible by 3 will be 27. So 25 plus 2, which is 27, and that is divisible by 3. So in that case, the value of p will be 2. Now the value of p could be between 0 to 9. So we can increase the value of p now. So if we now add 25 plus this is 27. So the next possible value which will be divisible by 3, that is 30. 30 means this 2 will be increased by 3. So it will be 5, and then the whole summation will be 30, and here the value of p will be 5. Now the next possible value which will be divisible by 3 will be 33. So in that case it will be 25 plus 8, and that means 5 has been increased by 3, so now it is 8. So here the value of p will be 8. Now the next possible value will be 36. So 36 means 25 plus 11. But the value of p cannot be 11 because it is a single digit number. That means the maximum possible value of p will be 8. And we need to find p plus q, the maximum value of p plus q. So it will be the maximum value of p, which is 8, and the maximum value of q, which is 5. So it will be 13. Now the next problem sum says that what is the absolute value of mod x plus 2 plus mod x minus 2, where x lies between 0 and 2. That means x is greater than 0 but x is less than 2. So x plus 2, since we are doing the summation, so this limit will not have any effect when we are dealing with absolute value. But since x is less than 2, so this will be represented as x minus 2 will be represented in terms of 2 minus x, as 2 is greater than x. And if we want to do that, then we have to take minus 1 common. So now we can represent this way, minus of 2 minus x. Now when we will fit this with this mod value, so it will be mod x plus 2, and this will be plus mod minus of 2 minus x. And we know that whatever it is plus or minus, the mod value will be always plus. So for x plus 2 it will be x plus 2 only, and for 2 minus x this minus sign will vanish as we are considering the mod value. So it will be 2 minus x. So this minus x and plus x will cancel each other, and the final value of this expression will be 4. Now the next problem sum says that if a, b, c and d are 4 positive real numbers such that the sum of a, b and c is even and sum of b, c and d is odd, then what is the value of a square minus d square? So whether that will be even, odd, or either even or odd, or that will be a prime number. So as per the problem statement, a plus b plus c, this summation is always even. Fine. And as per the problem statement, the summation of b, c and d, that is odd. Now if we subtract these two expressions, then it will be basically even minus odd. So from the left hand side, what we will have finally, b and c, since it will be minus b and minus c, so they will cancel each other. So from the left hand side it will be A and it will be minus D, right? And from the right hand side it is basically whatever is the value, we are subtracting a number which is odd in nature from a number which is even in nature. Suppose 8, and from there we are subtracting 3, so it will be 5. Suppose we have 16 and from there we are subtracting 5, then it will be 11. Suppose we have 10 and from there we are subtracting 9, so it will be 1. So what nature we have found here, that always when we are subtracting odd number from even number, the result will be always an odd number. So this summation will be always odd number. And when we will be adding these two numbers A plus D, when we will be doing, again we are adding, so 8 plus 3 if we do, then it will be 13. When 16 plus 5 we will be doing, this will be 21. When 10 plus 9 we will be doing, that will be 19. Then that means what we can conclude is, when we will be adding an even number and an odd number, their summation will be again an odd number always. So now what we will do, if we multiply this to, so it will be A plus D multiplied by A minus D, and on the other side we are basically multiplying two odd numbers. So from the left hand side we will be getting A square minus D square. We know this rule, this formula. And from the right hand side what we'll get, so we are multiplying this time two odd numbers. So suppose 5 multiplied by 3, it is 15. Suppose we are multiplying 7 multiplied by 9, so it will be 63, and so on. So what we are getting here is, when we multiply two odd numbers, the result is also an odd number. So here whatever will be the value, the result will be always odd. That means as per this given options, our option will be option B. Now the next problem sum says that we have to find the LCM of these two given numbers by using synthetic division method. So first we will write these two numbers and then we will divide by the possible lowest prime numbers that we can divide by. So here both the numbers are even numbers, so both the numbers will be divisible by 2, which is a prime number. And if we do that, now we are left with 81 and 27, and both the numbers are not even numbers, so we cannot further divide by 2. And between 81 and 27 the common divisor is 3, so further we will divide by 3. So the LCM of these two numbers will be, here we have 6 2, so 2 2s are 4, 8, 16, 32, 64, and here we have 4 3, so it will be 9, and here we have again 9, so it will be 81. And when we will multiply 64 with 81, then it will give us 5184. With this I end today's class. Stay safe and stay healthy. Thank you.